be able to.
Cool.
All right. So first thing is introductions. Do we have any new faces here? Don't think so. So move on to release planning and updates.
All right, I could speak to the platform side. Pack is being released today or tomorrow at latest. We've had an RC out there. No issues found or reported as far as I'm aware. But yeah, that's what we've got going on.
We're going to ship a release candidate for the life cycle this morning.
On the learning team side, we finally had CNCF follow up on the Kata codation. It looks like we can embed the tutorials right in the website. So we'll probably start doing that soon.
All right. Moving on to first item on our agenda, the SBOM RFC. I'll let Sam start with that.
Yeah, just trying to share my screen. Okay. Think the only updates that I have here are from Terrence's comments about having the ability to see what SBOM format a Buildpack supports on the registry. Maybe, so I added the SBOM key to the Buildpack DOML, which is an array of values. Currently, we only allow, or I propose allowing Cyclone DX and SPDX, but we could add more in the future. We can also use this metadata to add warnings from Pack or other platforms, like if it notices multiple, like different formats in the same build process, it can warn that the SBOM may not be complete. The other comment that Patrick made this morning is that Cyclone DX apparently has a concept of bomb references. So you could, in the final merged Cyclone DX bomb that we're generating, if we see an SPDX bomb for a specific layer, we could actually just refer to that and say that instead of a Cyclone DX bomb describing that layer, here's an SPDX bomb that describes it, and that could potentially be used. This, I guess, also helps more with like heterogeneity around SBOMs, and he also notes that there isn't really a globally accepted format, and in the future, like in the current future, it seems very likely that there would be a mixture of SBOMs all over the place. I think the only real blocker or thing to figure out at this point is how do we restore bill of materials across different builds. But apart from that, I think the RFC is pretty much done.
So this SBOM array is just to indicate like additional SBOM formats outside the legacy CNB format, because I assume we're going to keep the legacy CNB format. I'm not going to say forever, but like forever seems like the best word that I can use. So this is just additional SBOMs on top of the legacy format.
Not really. If you move to the new API, it's gonna assume that you're supporting these two formats. The old legacy format would go away. So if you if you want the format, you can be on the older API.
All right, that's good to know. Because I thought that there was some discussion at some point of keeping the older legacy format, because in some ways you can have like some enhanced amount of data because it's such a free form field. But if the plan is to ditch that as soon as we make the API swap over, I'm just as happy with that.
I think the only reason I mentioned the legacy format here is for backwards compatibility reasons, where if a build pack cannot update to the new API and the BOM format, we should still have a way of preserving that data and showing it to the user somehow if they want to make some sense of it. But I don't think it makes sense to support the legacy format in the future APIs, because there's no real like tools out in the wild that support that format. There's
Yeah.
no structure.
I 100% agree. Thank you.
Are there any outstanding questions on this that anybody feels like would block them from moving forward to FCP?
This, I would say, mainly Emily
Good
and I
stuff.
need to figure out the issue. So as of right now, we did merge an RFC in that restores layer specific SBOMs, or SBOMs in general, but that isn't implemented anywhere. So I think from the core team sync yesterday, we wanted to keep that functionality even though it's not implemented, and have a way to restore the SBOMs as opposed to leaving it to the Buildpack author to figure it out how to do it.
Can we just put it on disk in the image for now, or put a copy of it on disk in the image, and then like, is there a slightly less ideal, but way that moves us forward? Because right now we put the SBOM in the image already.
Yeah. I think even if you put it on disk, how would you have that available for the next build?
So if it's a layer that's cached locally, cache it locally with a layer.
Okay.
If it's a layer that ends up in the remote image, then store it in the remote image and keep it around.
Yeah, I think Emily wanted to figure out the specifics around how that would work. That was the only thing blocking this.
Makes sense.
Right.
Does it block the RFC, or does it, is it just an implementation detail that we want to figure out?
I mean, really up to all of you. I had initially pointed that to a subsequent RFC or during implementation, but if we want to address it as a part of the RFC, we can. Otherwise, we can just point it until we get around to implementing it.
I agree that we shouldn't have the behavior where you have to regenerate an SBOM for a layer that already exists, that was generated in a previous step. And so like that seems blocking. But given that it feels more like implementation decision to decide exactly how we recover that, layer, and it might be platform dependent. For me, it doesn't block it, as long as we say that yes, we do need the correct behavior. But whatever people feel like.
If it's worth anything, currently for most of the Paketo build packs, we regenerate the bill of materials for like every time we do a rebuild. Like as soon as we're done doing the logic that selects the dependency, we create a bill of materials and then do the logic to whether or not we actually install it. So having the ability to restore it is only really valuable in the case where we're doing something like scanning our node modules, which we use a third-party plugin to do. So it's not a huge press for us right now. So if you would like to just hold off on that, that's fine as well. But I imagine that it might be important to others.
I think all the Java Paketo Buildpacks do rely on that, and they currently use store toml or some other way to store that thing in the interim and then restore it back into the appropriate SBOM table during the next rebuild. But I think with this, the SBOMs would also be larger, so we'll have to figure out a way to store them in a way that we're not causing issues on people's production clusters.
Mhm.
But I don't know if you want to do it as a part of this RFC or the other one, because there are also some open questions on how we store the SBOM in general, like apart from the restore or rebuild workflow, like how do we store it in general? Currently, it's on a label, but that won't be feasible, I think, with us generating SBOMs from a bunch of these tools. Like, for example, the node modules one sometimes generate SBOMs, which are like a couple of MB in size. That might be problematic.
For sure.
Any other open questions about this? I know Terrence, a couple times you brought up some concerns. I really especially shared initially about supporting multiple SBOM formats. Or how are you feeling about it?
I mean, I put a comment the other day that Sam addressed where I said that you convinced me we needed more than one, just because, there is no winner and different use cases, different SBOM formats. But I just, I think the Buildpack Tomlin changes was kind of the thing I was looking for. It's not the most ideal thing because in theory you could lie or whatever, but I'm assuming Buildpack authors, you gotta trust them to some degree. So I think they'll just help platforms, and like if a platform only supports one SBOM format or whatever, they can at least know ahead of time that this Buildpack won't provide them the stuff they need. And they can either put out a warning or something, right?
Got it.
Technically, the lifecycle could verify the metadata on the Buildpack toml against the file formats the Buildpack generates at the end of the build process, but I didn't include that in the RFC because that seemed like a optional thing, but we can enforce that if you want.
Is the list in the RFC, do you specify the list is valid on a meta build pack as well as a build pack? So you probably don't want to allow it on a meta build pack because you can calculate that from other build pack tomls. It could be less accurate.
Yep, I can add that it's only valid for normal build packs, not for for meta build packs, lifecycle would handle it for you.
Awesome. All right. Is there anything else on SBOM? We're about a third of the way through and we have 3, so.
No, it looks good to me. It just seems like Sam and Emily need to touch base and figure out whether it's a blocker for her or not.
Cool. Next one is additional exported layers. I think this is also Sam.
Did we want to do this at the end, or because we thought it might take a bit more time?
The Docker file one at the end, I don't have anything specific for, and this seemed more, I don't want to say controversial, but like there's more to figure out, if that makes sense. So I think we put this one first, but if you'd like to skip it, that's okay too.
Can share if you want. So This RFC tries to solve the issue where if the build pack or the build process wants to export layers which do not include the /layers directory or the workspace. There are some use cases for it where you want to install software in specific paths, and those paths are rebaseable, and you want to preserve them in your final application image. So some examples that I have here are like op directories or like Lambda extensions or like other common standalone software. I know some of the rel packages also can be installed as a standalone thing in their own directory inside opt. Similarly, like if you want to preserve some configuration or settings in the home directory for a user rather than regenerating it during runtime through some execd hooks, you could also do that. And the main idea is to have these kind of changes be made without like relying on hacks like creating symlinks in the stack, which are then populated during the build process. And this is sort of orthogonal to the other Docker files RFC, since I want to create these folders or export them post the build process as opposed to before it. And currently the stack packs or the Docker files proposal does not allow for functionality like this. But the main blocker here was the implementation of it and how this might go in a different direction than what we're trying to do with the new, like removing stacks and the new Docker files RFC. So I just wanted to figure out if we can preserve this functionality, but maybe implement it in a different way so that it's compatible with what we're doing with the other ones.
So one of the comments I believe Terrence brought up was how, I guess, the implementation of using volumes at the stack layer would essentially create some sort of tighter coupling between build packs and the stacks. I wanted to kind of dig into that a little bit more because I feel like that is kind of counter to what we're hoping to get to, where it's like the ecosystem of build packs and they could do whatever they want within their domain and not rely specifically on the stack specific implementations. I don't know what your thoughts on that are. Are there alternatives that could work differently?
So there are alternatives in the sense that you could declare the volumes or the places that a build pack wants to export in the build pack toml, so that when the platform is creating the builder or whatever, it can read that and set the appropriate things. The other thing to note is that a build pack does not necessarily like have to be tied to a specific stack. It can, like, it will be past the list of places it can export, or the list of folders that would be exported during both detect and build time. So if it's compatible, it can still choose to support, like, hey, you don't have volume X, that's fine. I can write my stuff to someplace else or make it compatible, but it works better if you have volume X. So a build pack could still do that if it needs to. It's sort of similar to like the whole hooks proposal with the Docker files. Like if a build pack needs a specific requirement, I guess, which can only be installed either via hook or via stack, it should still be able to do that.
So I think that's part of the blocker in my mind, is that it seems like the build pack, right? Like, let's say opt for some, as an example, right? If they wanted to add these extensions, if they have a way to not need these volumes, right? Then why are we introducing the complexity of providing these volumes? And if you're saying that they do need it or work better if they did have it, then it goes back to that, like, now this build pack, what would fail essentially, or would not pass. And so therefore it is kind of coupled to the implementation of a stack. So I'd like to maybe explore more the kind of alternative suggestion you had, where if the build pack could declare, these are the things I'd like to be able to export, and then maybe allow the platform to, kind of make that decision on whether or not it's able to. I wonder if that would be better.
And that also makes sense. So like a build pack would declare a list of additional paths that it wants to be able to export layers from, and then during the builder creation process, or when you're running analyze, it could figure out if, well, I think it might be easier during the builder creation process if the platform could just provision all of those volumes, or like declare them somehow in the builder metadata, and then when it's actually doing the build process, it could provision them. If a platform does not have builders, it could still take a look at the bundled build packs and try to provision the volumes that the build packs are requesting.
Could it be part of like the order toml stuff at the start of the build?
Yeah.
I'm trying to think what order toml does, and doesn't that just provide the build pack ID?
Yeah.
So I'm trying to figure out how, because it's at a build pack level, right? That the build pack itself is trying to request something.
I mean,
yeah, I don't know. I guess I'm just thinking you need the list of build packs at build time to know first, right? Like, you're not, like Sam was saying, you're not always going to have necessarily a builder that has all the build packs. Like, you might be downloading the build packs at build time.
Yeah, I definitely see the complexity, because for one, are we talking about all of the build packs available on a builder, right? And aggregating all the volumes that could potentially be used? Or is it after detection saying, okay, these were the detected build packs, and these build packs then want these volumes or this exported directories? For me, the latter would be preferred, but I'm not entirely sure how feasible that is.
I think the latter would be preferred, but it might make the implementation more difficult. I could potentially imagine, so even with platforms like Tecton, I could potentially imagine the platform being able to do that with a single volume if before it seeds its privileged permissions, like and moves on to the build flow, if it can, even if it has a single volume, if it can create the appropriate symlink so that the data is preserved at the end for the lifecycle to export all of that out into appropriate places, that would still work. And then for a platform like Pack or Kpack, which can run things in individual phases, they could just use the output from the previous phase to mount the appropriate volumes in the build phase and keep them around during export.
Something slightly different, but when we're essentially providing these volumes, I'm assuming this is ultimately replacing the directory that the build pack is requesting, right? So if you do the, root opt directory, right, then basically anything inside of there vanishes from the build process.
Yep, it's similar to the way the app, like the app directory currently works. Like the semantics around these extra directories would be same as the app dir. It will be a clean slate on each rebuild, and it'll be up to the build pack to figure out how to repopulate it.
Well, I guess my concern is more or less that if there's content in that directory provided from the builder itself, that the build packs could essentially be removing content provided by the builder that could create other problems.
That should be easy to check though, right? Like if those directories are empty or not.
Right. And so I wonder if that's part of this RFC to mention that that would be a restriction that we'd want to put.
Yeah. So I guess the alternative implementation would be the build pack declares the parts it needs to be that it needs the lifecycle to export it, and the platform plus the lifecycle have some safeguards to make sure that they are actually exportable, and the platform makes sure to provide those volumes however it can during the build process.
Yeah, that should work. May work. I'll take it back to May. That may work.
I'll try to update this, and I'll try to see if I can accommodate. I mean, it's fairly easy to accommodate both PAC and KPAC for this. I'll see if I can try to accommodate something like Tecton.
Yeah. Cool.
So the use case here is you have some stuff that has to live at a really particular location in opt, right?
Or some other directory, yes.
I mean, like your specific use case is about a single, it's just about opt, is that right?
And a couple others, but yeah.
A couple others at the same time in the same build?
Yes.
Yeah, interesting. I was gonna say, you could just make opt the app directory. And then
I
have
have
your build
tried
packs, you know,
I've tried that, it doesn't work.
okay. I worry about the complexity. Like, I think I have kind of similar concerns about coupling with Stack, but like, so far that, whole API is centered around, we have this, way of setting up the environment and keeping each layer isolated from each other in a designated directory, right? And I think we have needs that extend beyond that, like the ability for multiple build packs to share a layer, right? And so it doesn't feel like we shouldn't do anything like this, if that makes sense, or that allows more layer sharing, maybe that allows more kinds of customizations than base image. I just worry about the one-offness, if that makes sense.
To me, this is like the same amount of like whatever we have with the app directory, it's pretty similar. I just want to have multiple app directories. That's how I'm thinking about this.
Multiple app directories is interesting.
That's how I have thought about this. Like at the end of the day, like these parts are just different app directories in the same build process, and I just want to write stuff in all of them.
I've thought about multiple app directories before, now different context. It's like if you have a bunch of build packs and say one build pack processes, static assets in a mono repo application, in a subdirectory, like should a build pack have a way of saying, hey, for subsequent build packs, this is your new app directory. Go process this stuff instead. When I work through that,
also work for me. Like in my use case, it's one like typically it's one build pack looking at one specific directory. Like I can model that. Like even if it's not, it's easy to break up my large build pack into smaller build packs that model it to one app directory that's visible to them, which can all be different. That also works for me.
So a reason you coupled it to the base image initially is that the app directory is currently coupled to the base image.
Yep.
If we uncoupled the app directory from the base image and said you're not supposed to include the app directory at all, and then allowed multiple app directories where the first one is the working directory, but then they're all accessible otherwise, and they all have the same app directory semantics, that looks pretty close to this, right?
That works.
And then the platform
But
would
no-
just decide, sorry, go ahead.
But no
I-
app, right? Just the behavior that you described, but an empty directory. That's a question.
For me, or for Sam.
Yeah. Yeah. I guess either one.
So you're saying like, would you just not put the empty directory in the base image for the app directory?
No, I guess I'm just
Question.
asking about.
Sorry.
Yeah. Sorry. So you like, as you were describing the multiple app directories, I was questioning if we're actually talking about the workspace with like the app source code, or just arbitrary empty directories that can be like layers, you know,
I think we're
like
talking
layer
about,
directories.
I think we're talking about the app directory, like whatever directory ends up with source code, or the user source code in the end, when the build starts, I mean. But like right now that's coupled to the base, like your build time base image says, this is my app directory, right? And that means if you added multiple app directories, the base image would have to say, these are the approved app directories. But if we removed that coupling, then you could specify what the app directory is at build time,
Yeah,
or
yeah.
Buildpacks could specify it or something like that, right? I wonder if that route, if you decouple that, like remove that complexity, that lets us, that opens it up to the ability to specify more inputs into a build, right? Maybe they're not called app directories anymore, which could be a little less specific than like, Buildpacks claiming volumes, except for this other one that's special, that's the app directory, right? If you like get rid of all the app directories in the base image and then say, during a build, you're allowed to provide source code in any number of locations in the image. And the first one you specify is passed to the Buildpacks as the app directory, and the rest are accessible one way or another, right? Then is that cleaner?
Yeah.
does that open other use cases up maybe?
I mean, that opens up more use cases than what I need. Like I don't need dynamic selection for the source code. I just need X places to write to, whether it's decided by the stack, by the build packs, I don't care. I just need some way to specify that these locations are available for the build pack to write to, and they will be exported.
I think it's always bothered me a little bit that there's exactly one directory that has all of the input at build time, right? That it's like kind of makes it feel like it's very centered towards building a specific kind of application. And if that were a default, right, that there's one directory, but actually you can, mount your tests over here. You can mount your source code here. You can have multiple source inputs if your app is, has multiple source repos that build it, right? And not being restrictive about where those appear, right? That sounds like a thing that a Docker file will let you do. So,
If the stack pack RFC could run post the build process, that would also solve my issues. Like I don't even need the actual content to be there. I just need it to look like it's there. So symlinks would also work.
yeah, that makes sense. because you want to create symlinks to layers that got generated.
Yeah.
And you don't want to create broken symlinks at the beginning.
That's, I mean, that's a bit dangerous, and sometimes that also couples the buildpack logic with the hook logic. The hook will have to know all the things that the buildpack would.
Yeah. It's gross. I'm not arguing for that. It's the only hack I can think of.
I mean, that may be what I might end up relying on if nothing else works out, but I didn't want to do that, because then I'll have to figure out a way for those hooks to talk with the buildpacks to figure out which places it needs to create some links in.
Makes sense.
And then I'll also be duplicating a bunch of detection logic, or I'll have to figure out a way to pass it in the provisions and requirements.
I think it doesn't feel completely wrong to allow Docker files to run after the build process. I worry that it creates a lot of complexity. It's like now Buildpacks are executing in an environment that has some stuff and then may also have some stuff later that, especially because currently it lets you replace the whole base image if you want to. What would that look like, right? And then, I worry that we added a lot of complexity with the original Stackpack RFC, and we cut it down with the most recent changes. It sounds like a way to add a bunch of complexity back. Or it'd be good to deliver on they run before we deliver on they run after, if that makes sense. But multiple app directories doesn't feel wrong to me. That feels like it maybe solves some problems that I've seen come up a few times where people are forced to consolidate things into a single repo with submodules or whatever. And then if it allows flexibility where you could say, if we decouple it from the location in the base image, and it allows flexibility where you can say, actually here are all my inputs in different places in the image, and I'm going to constrain the image. Yes, these all end up in the final image, and they start with whatever contents the user provides and are empty from that point. It seems relatively safe. So, and it's not too far off from what you have, I think.
In that case, do the Buildpacks then have to check each app directory? I assume you would probably change the name of that input, maybe to not be app directory. But so like if I'm a Buildpack, and you have potentially like you split apart a monorepo, for instance, into like there's subdirectories as different inputs, then does each Buildpack need to inspect each of those input directories to see which one they care to process potentially? Is that what you're envisioning?
I think in the normal case, so right now the working directory for a Buildpack is the app directory. And so in the most common case, the first app directory you specify is probably the Buildpacks working directory, right? And so Buildpack gets source code like normal and doesn't have to know anything about the other inputs, right? But then if we had some way of saying, hey, this Buildpack supports additional maybe named inputs, like it knows about an environment variable, or it expects to, if there's a value in an environment variable, getting closer to the same way you were saying, right? Then it can find the additional app directory.
Isn't that pretty close to what I have right now?
Well, what you have is like I think, unless this has changed, it's like a JSON list of app directories specified in a single environment variable, right? But I wonder if there's a way we can have a contract that's a little less. I think we do too much JSON in environment, JSON in places, JSON in files and environment variables and stuff, right? If there's a way to say like could you specify a test directory, right? And then there's CNB, or maybe not CNB underscore, maybe if during the build process the user says test:/test, then CNB underscore app underscore test or something based on the name of the thing becomes the location of the test input. And then now during the build, there's a new directory that contains tests that's accessible to all the build packs, right? It's just one environment variable that the build pack expects to receive. And then if build packs don't expect to receive a test directory, then they don't care about it. Something like that. But maybe like the trick is requiring a special input during the build process itself when you have more than one input, right? And then that takes the coupling away from the stack. And oh yeah, sorry, time check. I actually didn't have all that much to chat about on the Docker file when I was just going to call for approvals. Does anybody feel strongly like we should move on from this one?
I think there were a couple action items that I still haven't seen. I think the big one is we're still having issues loading the page. So I thought we were going to create a new PR.
I fixed it. I thought I fixed it yesterday. Okay. If you go to it, it should load now. It's still loaded on mobile. It's completely stopped loading in your browser, but it's still loaded on mobile if you refresh enough times. And so I use that to close about half of the things. And so now I think it loads on desktop again.
And then the other thing was, if I remember correctly, like the naming of the files, we're going to update those. And then I believe the term hook was somewhat still contentious.
Naming of the files, the term hook, yeah. Okay, so before we jump on Sam, we keep moving on to the Docker file one. Do you have any last? Okay, if you want to sync up on maybe a way to frame it as like multiple inputs, that seems really interesting to me. I think there are use cases there where I've seen like we could enable some more generic things that are interesting, maybe around testing or whatever, that are close to what you have, but I think keep the coupling away and frame it more like multiple inputs. Cool. Okay, sorry, Javier. Unless anybody has anything else on exportable layers, we can move on.
Nope, I'm not in a particular rush, right? I just want to make sure that if there are people that are interested in it, we could keep the conversation going or time boxed like we hope to do. But yeah, I think the things that I mentioned are the things that I've noticed thus far that are still missing. I don't know if there are comments associated to it because I haven't gone through all of them, but it does seem like there's still a decent amount of comments that are open.
Yeah, the comments that are open are mostly addressed. I'm just waiting for other people. I see Joe has one new thing here, but I was just waiting for other people to say, yep, they're okay with the answer and close it. I didn't see anything actionable, but I could be wrong. But you listed some things there. Sorry, I just forgot what it loads now. What was the other one?
So yeah, so now that it loads, I could probably go in there and add my comments about some of the naming stuff we discussed in the last meeting.
The name hook was one, right?
Yeah.
Does anybody have better suggestions for hook? I don't have a strong opinion about this. I don't think we should make up more words. That's why I like hook.
Yeah, no, I agree with that. One of my concerns with hook was that to me, it implies something a little bit different, like a webhook, like a sort of asynchronous fire and forget thing. But more important to me is like if we can tie it to something that exists, like actually I was thinking I was reading through the docs for Dockerfile from and stages, and they describe the from instruction creates a build stage that defines the base image, that blah 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 blah. So like there's a few terms in there or concepts that we could use, like stage or base dash image, or even from, that I think might, you risk tying it too strongly to something that isn't exactly the same thing. But yeah, even like from, just cmb/from is the directory from.toml. I don't know.
That's interesting. Froms.
But it wouldn't be, well, I guess the directory would be plural, but like each individual one would be like, it's like a stage, I guess. I actually feel like Docker kind of overloads the term stage because everything in the Docker file, well, no, I don't know, maybe not.
We use stage a lot too to mean the phases of the life cycle sometimes.
Do we do that? I mean, I think officially we talk about phases. Maybe like casually we talk about stages, but
Sounds be that. Would it be the something stage, or would it be called the stage, or I don't know, staging process? We used to call the build process staging on the old Buildpack API, at least on the Cloud Foundry side.
I'm not opposed to the term staging. I think that makes sense. And this is all pre, right? Like pre-build, not
Yeah.
post. Yeah, so staging makes sense.
Stage is the build. It's pretty good.
Is it-
Because when we use hook, I expected a post hook as well as a pre-hook.
Yeah, I agree. But that's just the best thing I could think of at the time. It's not a good. It doesn't really capture it.
What about extensions? Like base image extensions or extends?
Extents.
yeah, I thought about that too. I think that seems fine. I don't think it ties to anything that like any existing concept, but that's not necessarily a requirement.
Yeah, I would just say probably avoid extension because we have the extension spec, which might be confusing.
So is
Yeah.
the detection for hooks and buildpacks are run together, right?
No.
No.
Yes. They run together. You're right. But with all the hooks detect things first before the other ones, but they all run in parallel. Yeah.
At least to me, like this, if we had bin detect for everything, and then if a buildpack, I mean, this is also going a bit back into the buildpack territory, but you could have like a detect binary, which is common, an extends binary, and a build binary. So the extends binary outputs what you have. Detect is common. So if buildpack needs something, it can still do that. And then the build part is the normal build part for a buildpack.
So these then stack packs would be allowed to have 3 binaries, is what you're saying.
Or yeah, it couldn't be a no. It can just have a no op build. Like you can just ignore build, will be a no op build.
I think the ordering would be weird because you couldn't run any of the stack packs build scripts until all the extend scripts finished. So go extend later, build. Doesn't bother me too much, but I don't know what the use of the build script is if you can modify anything on the base image. Also, it feels like it encourages people to put things that could be modular Buildpack logic inside of these stack associated things that live at the base image.
I think the idea was to. So I'm imagining a lot of these would have repeated detect logic in the actual buildpack and then the hook you write. It's trying to hope to get around that by having like a single thing that does the detect, then leaves some parts to extend and some parts to build, but that might get too complicated. Because I'm guessing a lot of it would have like the hook would detect something based on what other buildpacks detected or something of that sort, right?
Maybe I'm not totally clear in the workflow. So like the way I imagine this working is because they participate during detect, another Buildpack could require something. They can only provide, they can't require, right? So they get requirements from detection and then they pass it on to their build script that can modify the base image. Where are you worried about duplicate logic?
I guess it's just that I'm guessing you'll have some coupling between what a build pack requires and what a hook provides. Having that in the same place would make it easier, but maybe that's just me.
Like maybe a build pack wants to also, you want the same build pack to be able to do the base image thing and provide layers on the thing. But now yeah, I see what you mean.
Because there are benefits to doing it the normal layers way, right? You get your base ability, you get some other levels of caching beyond the normal Docker file caching, and
I think it becomes a little complex because you have to figure out are the build plan entries coming from the requires, the previous build packs going into the extend, or the build. Maybe we could do this first and then come back later and add the other kind of build functionality. I guess then you're just saying the name of the script is weird. I don't care about what the name of the script is for stack packs. If we wanted to call it bin extend, that instead of bin build for now, that's okay with me, but I think other people had strong opinions about it. They should look more like build packs, maybe just implementation wise, so that because the interfaces look so similar right now, the lifecycle it wouldn't be that. I think Emily thought there were some benefits. Maybe if you want to put the suggestion for bin extend in the RFC and tag Emily, and if she doesn't say no, then I'll change it. How about that?
Yeah. Sorry, Sam, go ahead.
The other thing I wanted was like the build or the extend, whatever binary that is, if that had a way to write out the Dockerfile arguments that are passed to the build process, that would be great. Like if it writes a TOML file or some file out there with the key value pairs of the build argument name and the build argument value, that would be beneficial, because then I don't have to worry about incorrectly generated Docker files because of this whole templating logic.
I think it's already in there.
It allows you to pass build arguments.
Yep, in build TOML, launch TOML, whatever they're called. There's build args. Let's see where I put this. Build arg. Is that in there?
Yeah.
Yeah, additional args table in provided as args in build.toml. Oh, and launch.toml.
Nice.
Right, for each of the things. So I thought it should be covered.
So I think one of the things that I'm really like cautious about is the idea that this is going to bring about a lot of confusion, given that the structure is and the interface is very, very similar to a build pack, but not at all a build pack, right? And so like even as you were both discussing like how it works, right? I was thinking like, wait, can this actually be inserted into an order, right? And does it work just like a build pack? So I had to like go back to the RFC and be like, okay, no, not at all, right? Like that's not even included in any form or fashion. It just happens to be used in the same process, but they're defined completely separate, right? But then they still look very similar. So it's just like my mind is kind of toggling back and forth between, are these real build packs or are they something completely different?
I think it's a virtue in this case, actually, like because we're not calling them build packs. Like I know where you're coming from, and I think we really had to be careful with that with stack build packs because we were calling them build packs. But in this case, I don't think it's on the table that we would rename hooks to hook build packs or something, right? And so in that case, I feel like the parallels are a virtue because you can kind of quickly, even if there's like differences, you can kind of quickly go, oh, well, I get what detect does. And then I may need to read build or like read some of the documentation for build, but I still kind of get what it's going to do. But I think that works because we don't use the term build pack. Otherwise, I would probably agree with you.
So I think the concern that I have is more of where I'm creating the detect, binary or script, but then I'm having to think of, in some sense, the context of what's possible within this detect or how it operates, or the same thing for the build, right? within the context of, am I writing this hook versus am I writing a build pack? And if I look at documentation for how to work with build packs, right, that could very easily overlap with documentation that may actually be applicable only to the hooks. And that's why, like, changing the file names was one of the first things that I kind of proposed, right, to at least eliminate some of that context.
We're at time. I just wanted to say, it seems like two outstanding things are the name of the thing and how close it looks to a build pack. If somebody feels like it looks too close to a build pack and wants to concretely suggest we rename some things, can you actually suggest that on GitHub in the commit, and then we can ideally with a proper suggestion, so I can hit the button if that makes sense. If we decide to do it, and we can have a discussion there. And then if somebody has an idea for the name, if you have a really concrete idea for the name that's like, it will be called a staging something, or whatever, just be like really concrete about, this is what I think it should be called. These are how it should be used and how the directories should look like. I feel like it's a very large RFC and there are a lot of different ideas. They're all very good ideas, but I want to make sure that we kind of keep moving forward with some concrete when people want to change. Right. Thanks, everybody.